In this video we explain how singular value decomposition leads to principal component analysis, or PCA, because apparently one acronym was too merciful. Suppose we have k data points in n dimensions. Put them into a matrix X raw, with one row for each sample and one column for each feature. Our goal is to replace each n-dimensional data point by an m-dimensional data point, where m is smaller than n, while losing as little information as possible. So yes, we want compression, but not the kind where the data comes back looking emotionally damaged. Step 1 is to center the data. Compute the mean vector mu, and subtract it from every row. Equivalently, subtract the mean of each column from that entire column. After this, each column has mean 0. Step 2 is to compute the singular value decomposition of the centered data matrix X. Write X equals U sigma V adjoint. The columns V1 through Vn form an orthonormal basis of directions in the original feature space, and the singular values are arranged from largest to smallest. For PCA, we keep the first m right singular vectors, namely V1 through Vm. These are called the principal directions. Roughly speaking, the larger the singular value, the more important that direction is for describing the spread of the data. To compress the data, project onto those principal directions. Put V1 through Vm into a matrix V sub m, and define Z equals X times V sub m. This Z has k rows and only m columns. The ith row of Z is the compressed version of the ith data point, because apparently multiplication by a very special matrix counts as insight. If we want an approximation back in the original n-dimensional space, multiply by V sub m adjoint and then add the mean vector back. So the whole PCA recipe is: center the data, take SVD, keep the leading singular directions, project onto them, and reconstruct only if needed. And here is a tiny Python example. In real life, this is the sane approach. Compute the centered data matrix. Call numerical SVD. Keep the first m right singular vectors. Project, and reconstruct if you want an approximation. Please do not calculate PCA by hand unless you are being graded, blackmailed, or both.